Recall the definition. If the distribution of a random variable x is approximately normal, then you can define another random variable t, which is x bar minus mu divided by s over square root of n, and it follows a distribution that we call t distribution. The critical values of t are denoted by t sub c. They are different from z sub c that you learned before, so they are not the same. There are important properties for t-distribution. For t-distribution, the mean, median, and mode of t-distribution are equal to 0. The t-distribution is bell-shaped and symmetric with respect to the mean, and the total area under the t-distribution curve is equal to 1, or 100%. The tail in the t-distribution are thicker than those in the standard normal distribution. The standard deviation of the t-distribution changes with the sample size, but it is greater than 1. Well, if you have a t-distribution gives you a family of curves. Each one is determined by a parameter that we call degrees of freedom. Degrees of freedom, sometimes abbreviated as df, are the number of free choices left after a sample statistic such as x bar is calculated. When you use a t-distribution to estimate the population mean, the degrees of freedom are equal to 1 less than the sample size. So this is the formula that we're following, calculating the degrees of freedom. So as you learn, t-distribution is a family of curves. If the degrees of freedom is 2, this is the black curve representing the t-distribution. The degrees of freedom is 5. This is the gray curve representing the t-distribution. And as you increase the sample size after 30 degrees of freedom, t-distribution is very close to standard normal distribution. Question: which of these statements are correct? Students' t-distribution is necessary when the population standard deviation is not given. T and Z are both test statistics that measure how many standard errors a sample mean is from the population mean. T is a statistic, a value that measures something using sample data. T is a parameter, a value that measures something using population data. Students' t-distribution is another name for the normal distribution. First of all, students' t-distribution is necessary when the population standard deviation is not given to you. If you have sample standard deviation, you're going to use t-distribution. T and Z are both test statistics that measure how many standard errors a sample mean is from population mean. Then T is statistic. It's not a parameter. So this one is not correct. T is a variable related to sample, not population. Which one of these statements are true? Students' t-distribution, unlike the normal distribution, changes shape based on the sample size. Students' t-distribution looks more and more like the normal distribution as sample size increases. The students' t-distribution gets wider in the tails as the sample size increases. Remember, we defined empirical rule 68, 95, 99.7 rule applies to the t-distribution as well. And finally, degrees of freedom is another name for sample size. So, students' t-distribution, unlike the normal distribution, changes shape based on the sample size. This is what we saw. This is the family of curves. It doesn't have a fixed behavior. It changes as you change n or the sample size. Student t-distribution looks more and more like a normal distribution as sample size increases. Let's take a look at this data set. Calculate the standard deviation for sample A and round it to 2 decimal places. So let's take a look at our calculator, enter this information into our calculator and do the computation. Let me share the screen with you. So first of all, you can go to Stat and then Edit. You can enter everything in L4, for example. I already used L1, L2, L3. I'm going to enter everything in L4. So 466, 520, 512, 513, and 498. Now I'm going to go to Stat again, and now I'm going to go to Calc. One variable statistic, and everything is in L4. So I'm going to change it to L4. Second, 4 gives me L4. Frequency list must stay empty. And then here, do the calculation. Hey, X bar or the average is 501.8 and the sample standard deviation is 21.5453 and so on. So let us go back to our slide. 21.55 kilogram is the standard deviation for this sample. The question says round to 2 decimal places. So that's how you end up with 21.55 kilogram. You can take a look at your calculator as well. 21.545, which is now rounded to 2 decimal places. So you have a 5, you're going to add 1 to 4. So that's how you end up with 21.55. Let us go to the next question. Now, you have this sample. Calculate T statistic for the sample. Assume that the population mean is given to you as 475 kilogram. And then round the value to 2 decimal places. So what is T? Remember, the way that we define T is x bar minus mu divided by S over square root of n. Do we have all of this information? Yes, of course. T is 501.8, which is your sample mean. Mu is the population mean, which is given to you in the question. It says, hey, use 475. So this is your mu. You're going to enter that here. What is S? S, we just calculated S in the previous slide. It is 21.55 divided by square root of n. What is n? You have 1, 2, 3, 4, and 5 data in your collection. So once you do the calculation, it is about 2.78. This is how you calculate your T statistic. X bar minus mu divided by S over square root of n. Again, if I share the screen with you, you can actually see the calculator as well with the information that you calculated before. 501.8, which is your sample mean. 21.55 is the sample standard deviation. So you easily calculate the T or test statistic for your T distribution.